what I'm going to describe today is how we use Terraform in automation paddle. And apologies in advance for anyone that is not familiar with Terraform, but you can understand at least the basic concepts we follow to ensure like we deliver our code reliable. But first, a little bit about me. As Pavel said, I'm Ioannis. I'm the SRE team lead at Paddle. I work with Paddle for almost 2.5 years now. I'm from Greece. At the moment, I live in London, and I come from a software engineer background. What we do at Paddle at the moment is we have a one-stop shop to sell your software. What this means is like you build your new software, you want the checkout implementation to sell your software. It's where we come in because we handle the tax for you, all the fraud checks, and what you have to do is just get a nice paycheck at the end of the month with your sales. And also what I'm trying to do now is bring reliability mindset to Paddle by following SRE practices such as SLOs. But let's dive into a little bit of the code. So Terraform is a way to manage infrastructure as writing code. So if you want to deploy the new service, you just write some kind of configuration file, you deploy it, and that's it. So it's the same practice with writing normal code. But why we need Terraform? We want to have our test environments as close to production as possible. So this will make things easier for testing. Everything you build looks exactly the same. For example, how you create a load balancer or how a service looks or anything really. So this templating will improve your reliability and it will reduce the context switch when developers changing teams because all the infrastructure looks exactly the same. And the last one is you should give your developer access to your production, but you should give them access using tools and processes. Even if the access with Terraform is indirect, it will unlock your teams to deliver without having bottlenecks around your department. And obviously, it's extra fun to play with Terraform. So the next thing I want to chat about is orchestrators. So what's an orchestrator? Orchestrator is just a simple GitHub repository. And we follow one simple pattern that one orchestrator is focused on one provider. By provider, I mean, for the first example, AWS. For example, imagine you have a Terraform AWS, which is a repository that manages all things AWS. So this can be anything related from networking, security, services, load balancers, pretty much anything you have in your infrastructure. A different one can be how you manage your database users and your database access. Again, different repository that is focused completely on that, how you manage access to your MySQL or Postgres databases. Similar and same question applies to everything. So you can have a specific one for how you manage your RDS, how you manage your Cloudflare, how you manage your Google Cloud platform, pretty much anything. And for every single orchestrator, we have some layers within the orchestrator. So there are 3 main layers, and Bootstrap is where we create all the Terraform dependencies that we need to run Terraform automation. This is usually an S3 bucket, IAM access, and KMS keys for encryption that we all need of them to save the state files. And this is the only layer that we plan and apply locally and commit the state file to the repo itself. The next layer is the foundation layer, and it's where you should configure more global settings for your infrastructure. For example, how you do networking, how you create clusters. And this is usually an optional layer when it comes to orchestrators because, for example, for how you manage database users, usually you don't have something global, so you don't need it. And service is probably the most important one. It's where most of your code is going to live. It's where you manage all your components that are part of the service. For example, you have a service called Awesome Service, and there you want to create an EC2, a load balancer, SNS, SQS. So all of this managed from this layer. And the last one is the Terraform modules, which is normal Terraform modules. And it's where you can have a template of how an ECS service looks, how Elastic Cache looks. So this way you achieve this templating, everything looks exactly the same. Now, within the layer, we have a directory per environment. We decided against using Terraform workspaces, if you're familiar, as we found them harder to understand and work with. And in our case, one environment means a completely different AWS account. In other situations, maybe an environment means a different region, depends how you structure your infrastructure. Within every layer and every environment, we have a backend.tf file where you specify what state file to use for this kind of automation. And the pattern we follow is one state file per layer environment combination, as you give you enough abstraction and safety that if you apply something on your development environment, it's not going to affect your production one. Then for every environment, we have different files like providers, versions, and it's a way to guarantee that we always use the same external dependencies, so we have no surprises. And within an environment, we have a file per component. So again, let's say you have an example service, you have example service.tf, which everything there is all the resources needed to deploy the service. And last, we use data sources to reference things out of this layer, and not plain text strings, as you want your Terraform to fail fast and not during apply stage. The next one is how we configure our GitHub repositories. Obviously, everything is in Git, as I mentioned, like version control gives you audit logs, gives you better access on the change management. Everything is easy. Some of the rules we follow is all the branches or the pull requests must be up to date with your default branch in order to allow merge, and we can enforce this by GitHub rules. I'll explain in the next slide why. And also we use code owners, where if you want your Terraform admins to always review, for example, the Bootstrap directory, they will be always review this. Or it's how you can manage that this specific team gonna own this specific file, so they always have to review this file. And the next one is how we go and deploy all these changes using Git and Terraform. So we do GitOps. We do GitOps in a different and traditional way. What it means, whatever is on your default branch is the source of truth of your infrastructure to all environments. So if you go and replay the master build, it will be no changes, and we actually go and make sure that the infrastructure looks exactly the same. For every single build, we run init, lint, validate, and plan. And believe me, the builds are fast and will take probably a lot of time before you have scaling problems. But the scaling problems usually are the most interesting and the best problems to have. Also, in the default branch, we run all the previously mentioned steps, but also it's where we apply the changes to every single environment. And after the apply finishes, it sends the appropriate Slack messages, so you know if it was correct, it was successful or not. So if it's not, you go and check what happened. And obviously, everything runs via Docker on RCI, and you use versions for everything, like what's your Go version, what's your Terraform version, because we want to guarantee that there will be no surprises during how we manage infrastructure. The other important thing is how you review your Terraform changes. Obviously, the most simple one is first you should review the config changes, so the code itself. So review the code, it looks okay, no, normal review process. The next one is to review the plan. The plan is, it gives you what is going to change. So we use a tool for that makes a comment to our pull request. You can see the link there with what is going to change. And it's responsibility for the reviewers to always review this and leave some comments on the author that maybe something looks wrong here. And again, as I mentioned before, we only review the plan if the branch is up to date with the default branch, because we want to guarantee that what is going to change it's actually true. And once we merge the pull request, it goes to the default branch and it applies to all environments. Other small bits that we found interesting and we use it a lot is we use tags. It will make everyone's life easier when it comes to who owns what, if you want to have better cost management. But we found these 5 tags very useful. One is like managed by, which is like usually Terraform, the environment you deploy, the component name, the system name, and the business unit. That can be engineering or, I don't know, success, support, different kind of departments within your organization. The next one, I'd recommend to think multi-region when it comes to AWS, for example, from day one, and how you structure your layers. The layer I presented before, it's easily scalable to be region-specific if you just pick a region between the layer and the environment. Another thing, when you run Terraform automation, you will see that concurrent builds can fail, and they can fail because they try to get the lock to run a plan or apply. How you avoid this is you use this flag, lock timeout, and it will when plan tries to get a state file lock, it just wait for 5 minutes. If not, it will fail. If something unlocks, you're gonna get the lock and go on. And then I would suggest to lock down your Terraform and external modules version and only apply only allow patches and security fixes to come in. This is mainly to avoid surprises, and it can be very interesting if you don't do that. And last one, try to upgrade your Terraform providers as regularly as possible. And this is mainly to avoid big bang migrations. At Paddle, we did the Terraform migration from 12 to 14 for all orchestrators within 2 weeks. No drama there, but now we try to be more proactive in this and do it quarterly, review what we can upgrade and bring it to the latest versions. Some challenges and trade-offs we have with this approach. Obviously, with monorepos, the build time will increase, and at some point, you will start running plans in parallel per environment and layer. Sometimes the infrastructure changes from all teams will be a lot, and often that's not a problem because your engineers are going to have to collaborate and speak between themselves. But other times, orchestrators will not be touched for weeks, so it's not like that big of a problem. But it's challenging how you can manage it when it happens. Another challenge is how you test end-to-end a single chain to an environment without going and merging your pull request. Usually, we allow the option to apply always via RCI a change to a test environment without merging your pull request. But your branch, you need to be up to date with the default branch. And also, when you do that, you are fully aware that if someone else merges their changes, then your changes will roll back. And as I mentioned before, we decided to use directory structure over Terraform workspaces. It's so much easier to understand and work with. Workspaces, they have their place, but we felt it's not the right one for us. And last one, that's some of my suggestions. I'd recommend to follow the previous structure as long as your department is less than 100 engineers. The number is a couple of magic numbers, so don't take it very seriously, but it's more like, I feel less than 100, this can work well. But when the times come, you can move the Terraform files with the service-specific configuration to a service repository and run the apply plan in the service pipeline. And if you follow the approach we suggested, then you're fully prepared to do that. And this is why we follow this approach. So when it comes, we can move this configuration to service repositories and not in the monorepo. The next one I suggest is don't go nuts with creating too many orchestrators. Try to be sensible. For example, if you manage databases, maybe it's good to have database standalone to one repo. But other than that, I'd recommend go as big as possible. And when times comes, split out things. And the last one, I'd recommend to use S3 as your backend to store your state files. Be very strict on who has access on these files, because sometimes you're going to commit secrets in there, which is fine because S3 can be very restrict. But you have to follow the appropriate patterns to make sure that only some people, or obviously only some automation tools, can access this and nothing else. And yeah, just go and do it. So this is me. And yeah, at Paddle, we're hiring to SREs, backend engineers, front-end engineers, product managers, pretty much everything. We try to double our department this year. So it's an interesting time to be around. So if you want to join, click on this link, send me something on Twitter, ask on the chat here. But yeah, that's me.